Hello, welcome to DDD. I'm really pleased to introduce for this session Hadi Ahmadi, and he's going to be talking to us about refactoring legacy code bases with property-based testing. So, Hadi, over to you.
Thank you so much. Hello, everyone. Good afternoon. This is Hadi Ahmadi, and I'm very glad to have you in this session. First of all, I should thank all the people, including organizers, producers, speakers, who put a great deal of effort into making this session happen. And I also appreciate the support of the sponsors who supported the DDD 2021. As you know, all the sponsorship funds of this year has been donated to the National Museum of Computing. So we can also consider donating to them, as what they do is so important to our industry. As I'm not the first speaker, you should probably know that there's a code of conduct for the DDD 2021. So you might consider reading and following that. As I said, my name is Hadi Ahmadi, and I'm here with you to speak about refactoring legacy systems with property-based testing. If you need to contact me, you can follow me on Twitter, or you can simply send me an email. I'm going to talk about a very, very useful technique about using property-based testing to build safety net around codes for refactoring legacy systems. We all work on legacy projects at some point in our careers. In fact, the majority of our time as developers is spent on maintaining the existing code rather than working on greenfield projects and writing new code. But the problem is the most legacy systems suffer from bad design, either because we didn't care about refactoring, or simply because of technical depths, or simply because of the bad design solutions. So we need to refactor the design in order to make it more maintainable and more readable. But the problem is most legacy systems do not have a good test suite. So that makes refactoring very dangerous and very difficult task. And you know, without tests, it's not possible to predict the changes that you make into a code base. You can predict how a simple change is going to affect the total behavior of a system. So you can easily make a mistake and make up a mess and introduce bug to your software. During this presentation, I'm going to discuss how you can use property-based testing to build safety net around your code, and that will help you to reduce the risks associated with refactoring legacy code bases. Okay, let's get started. So the plan is we're going for a quick introduction to property-based testing, and then we're going to see how tests can help us in refactoring, and finally we're going to see how property-based testing can help us in refactoring legacy systems. So when we talk about testing, we usually mean example-based testing. The way example-based testing works is that we write an example from a set of possible examples and assert that behavior against the system under the test. So then we use a variety of examples from different scenarios and different cases to create a comprehensive test suite. And this is a very common method and very useful method. And we usually, when we talk about tests, we usually mean this kind of tests, the example-based test. Although this is obviously a good approach, it does have its own drawbacks like any other methods. We are going to see the drawbacks, we are going to discuss the issue, and then we are going to see how property-based testing can help us in this manner. So the first questions that come to mind is that how many examples are enough? With these examples, do I cover all the cases? Is there any case that I cannot see right now but can introduce bugs and problems in my software? Even though there are lots of techniques and methods to address this issue, but we all have experience missing some cases and introducing bugs to our software. In fact, property-based testing suggests a general claim about a system's behavior based on a concrete scenario or based on multiple concrete scenarios. So the next problem is we as developers usually come up with very naive examples, as you see on the slide. This issue becomes more relevant when we are talking about complex algorithms and complex calculations. So your test will only be good if you have good examples that can exercise all the possible program states that you have. So if we look at the definition of the bugs and the nature of the bugs, we see that the production bugs are by definition the ones that we couldn't see them coming. If we could see them, we would have written a test for them and handled them in code. So basically the term bug refers to the scenarios and to the cases that were beyond our imagination at the time of the development. So that this is a serious problem. In conclusion, the method of example-based testing helps us to identify bugs that we anticipate, but not necessarily the cases that we cannot anticipate. As a point of clarification, I should note that I'm not against example-based testing. I'm not suggesting that they are useless. What I'm basically saying that there are some drawbacks to example-based testing. So we need to be aware of that, and we need to have a solution to provide a solution for that. The concept of property-based testing actually rooted in functional programming and was first introduced in Haskell's quick check framework. But obviously you can use that in any other paradigm or any other language. As you will see in this presentation, I will use C# language for writing my property-based tests. So there's no limit if you're not working with a functional language. If you're using object-oriented language, there's no limitation. Fundamentally, property-based tests are different from example-based testing. They use something that we call a property, some kind of meta test. So we need to define what a property is, and we can go further and talk about how they can help us to write a test. A property refers to a rule which dictates a behavior that should always be the same, no matter what kind of input samples you feed into your program. They will always have to remain true. So a property will then be coded into an executable test, and if you run them, they will assert the behavior of your system. As you can see on the slide, I've written a very simple property for my calculator, which simply says adding x and y, then subtracting y gives you an x. This rule applies in all cases. Regardless of the number you use, this rule should always stay true. However, properties are by themselves useless. They are just a rule. They are just rules that we need to execute them. So a property-based testing framework is there to make them executable. A property-based testing framework is needed to make your properties functional. So what a framework do for you is that the property-based framework generate the inputs for you and then run that values against your properties and check it will check to see that is your system working as you expected. So the framework generate inputs for you and it run the properties against the inputs that it has generated. And the tests are considered successful when the properties remain true against all the inputs. Property-based testing rely on a concept called generators to generate values. There are times when the values are randomly generated, and there are other times when a rule is followed, but when a rule is followed by that random generation. So you can simply write your own custom generators, or you can use the framework's built-in generators. The frameworks actually give you lots of capabilities and lots of features that you can use them to write your properties as you need in your situations and based on your requirements. For example, as you see on the slide, I've written a conditional property, and what I'm actually saying, the framework that you should not generate 0 as an input for this property. So this means that the framework will generate random numbers that do not equal to 0. This is a very basic example. I'm just trying to give the idea to you that how property-based testing works. As I said, there are lots of features that you can use in property-based testing frameworks. For example, as you see on the slide, I specify that I expect an exception in every case. So if anything other than the exception is received by the framework, my test will fail. Since this is the whole idea, you can obviously search for the frameworks, for the capabilities, for the features that they will give you to write your own properties. As you see on the slide, I've written a kind of custom generators. You can search for them. There are lots of ways to write custom generators. Of course, default generators are useful to discover unexpected issues and problems, but not possibly so great for scenarios when we need to generate some kind of a specific data for your tests. This is the whole idea of property-based testing. But I do believe there are lots of topics that you can search for them. There are a lot in this manner you can study about it. If you're interested in the topic, I recommend you to read the following book, Property-Based Testing with Proper, Erlang, and Elixir, which is a great book by Fred Hebert. He explained the topic very well. He discussed several different ways of writing properties. As you will find in chapter 3, he focuses on ways and techniques of writing properties. So you can obviously get that book and find more information about property-based testing. So when we talk about refactoring, as Martin Fowler defines the refactoring in his famous book, the refactoring is the process of changing a software system in such a way that it does not alter the external behavior of the code, yet improves its internal structure. So we usually use refactoring for improving the design of the code, for make it more maintainable and more readable, and make it so we can change the code more easily with low cost. Or maybe sometimes we refactor for some kind of non-functional requirements like the performance or better use of memory. So when we refactor, we are usually improving the design of the existing code. But the problem with refactoring is when we are doing refactoring, we usually we are dealing with a code base that are poorly structured and have poor test cases. And this is a very, very difficult task to do because the changes have unintended consequences. So first of all, to avoid any mistake, make sure you have a good set of tests. This is the refactoring always begins with this step. You have to make sure that you have a good test suite around your application. Testing is necessary because we are human and we do mistakes. We do make mistakes, and to avoid such mistakes, we have to have a good kind of test suite. So we are going to see how property-based testing can help us build a test suite, a safety net around our code, and then refactor our code to make it more maintainable. In the context of property-based testing, there is a technique called modeling. And the idea is to come up with an alternative implementation that we can trust, and so we can assert the behavior of the system against that implementation. For example, as you saw on other slides, I used the subtracting against adding function to check that if the add function is working properly. So an amazing but rare type of modeling called the oracle. Oracles are actually reference implementation. They can be from different languages, different packages, and we can use them as pre-written models. So we can assert the behavior of the system against that model. Speaking of models and oracles, when we are dealing with legacy systems, we actually have a very good model and a very good oracle that we can assert the behavior of our new code, our refactored code against that. And that's the legacy code itself. The legacy code, as we saw, works fine and the functionality is correct. So we can use the functionality of the existing code to check and assert that our new code, our new refactored code is working properly. So the idea is that using legacy codes as models and oracles. As you see on the slide, the idea is very, very simple. Our legacy code should act exactly as our new code, our refactored code. So we're going to apply this idea on our refactoring, but before that, we're going to see the mechanics and how we can apply that step by step on our code bases. So the mechanics is simple. No matter if you're using unit testing, if you wish to write integration tests, if you want to write acceptance tests, the mechanics are always the same. You need to keep a copy of your legacy code before start refactoring. Then you create a very simple property that to support your refactoring, which is legacy code should be equal to my new refactored code. Then you can start refactoring, and step by step you can run the test and make sure that your refactorings are fine and you haven't broken anything. Okay, let's see what it looks like in action. So I have to share my IDE here. Okay. Here we have a very simple solution. There is a class called movie rental. As I said, I'm using C# and .NET framework. Basically, you can use the idea in any other paradigm or any other language. I just use it because I'm familiar with C# and .NET framework. There is a movie rental class here. We have three kind of price codes, which is regular, new releases, and movies for children. Then we have an interface called iPaying customer that we use it for charging the customer. So basically, there's a method here at the movie rental class for charging a customer, and which takes an iPaying customer as an input, then doing some calculations, and finally applying that charge on the customer. This is a very simple code just to show you the mechanics of refactoring with property-based testing. We can start that and use our idea here. So I basically created an empty test project. In .NET Framework, there is a library called F#check. You can check it on NuGet and use it in F# language or C# language. I'm going to install that. I'm going to install the F#check adapter for XUnit. So step one, we are going to write a very simple property. So I need to change this to a property. And I can call this test old code should calculate, or maybe refactored code should calculate as legacy code. This is a very simple property. I will change this one to a property. Okay. So what I need to do that is to create a testable for that interface that we have, iPaying customer. So I'm gonna create a testable for this class. I'm gonna name it free customer, for example. I'm gonna implement that interface so I can use that. Having lots of typos here. Okay, this testable is going to help us test the behavior of the movie rental class. So basically what I'm going to do is to define a variable here, call this and basically increment the value based on the parameter, and we can so this is fine. This can help me to write my tests. Okay, what I'm going to do is to make a folder here, refactor. I'm going to I think I have already a folder for that refactor. I'm going to move the movie rental here. I'm going to call this refactor movie rental, which is my new class. I'm going to refactor this class. I'm not going to change this right now. First of all, I'm going to create my property. This one here. And I'm going to ask the framework to generate the values for me. So there are two values in the constructor. The first one is days rented, and the second one is movie rental price code. So the days rented is going to always be a positive value. So I can ask my framework to generate only positive values for me. So there is a class called positive int in F# check. You can use that. Days rented, I'm going to call this days rented, and for the movie rental price code, I can use this here, price code. So before I'm going any further, let's see how this is going to work. But I'm going to see it's like this to show you the parameters. So I'm going to run the property, and you can see the values are generated by the framework. So here I'm going to run this property. So the first one is the value 1 for days rented and children for price code. Again, 1 here, regular for price code. Again, 4 here, and new release. As you see, the framework is generating random values for me, 2 and regular. So we can continue writing the tests. The test as going to stop the debugger, and okay. So I'm going to pass this parameter here, and I'm going to pass the exact value to our legacy code into this. I'm going to create 2 customers, customer for refactor code, or maybe we can use kind of there's names here. Okay. So what I'm going to do here is calling the class and passing the customer here for this one, and obviously I can do that here. And finally, what I have to do is to check that the our customer for legacy code has received the exact amount for our new customer for refactor code. So as you probably guess, this test is going to pass because I've already copied the implementation here, so there's no difference between the 2 implementations. This is step 1. If you want to use property-based testing to refactor your code, this is the first step. So my test is passing, and as you see, I can, if I can find the input screen here, unfortunately I can find that here. Okay, passed 100 tests. So the framework has generated 100 values for me, and the code is working without the problem. So what I'm going from here, I'm going to refactor the code, and after each step I can easily run the test and see if I break something, so that I can revert that. So basically in real world development, what I'm going to do here every time is to commit my code. So this will stay here as a safety net for my code. So but I'm not going to do that. I'm going to change the name of this class first, properties for checking the refactor code behavior, something like that. I'm going to refactor the code. For example, what I can do here is to replace this switch case with polymorphism. I can obviously define a class here called, for example, interface here, iPrice code, for example, which calculates the charge for me. And what I can do is to pass days rented here. So I have three kind of price codes. So here I can implement this class, this interface. For example, one for each. Regular price code. And I'm going to copy this class. I'm going to call this new releases price code and children movie price code. So I'm going to move them to separate classes. And what I can do here is to just, for now, just copy the implementation. This is for regular price code. I can do this here, days rented. I can fix this one, and obviously so looks fine. Regular price code. And what I'm going to do here right now, just for a test, is to using this class, regular price code, I'm going to pass days rented here. So not this one, sorry. So I'm going to test if my refactoring is fine. Let's see. Let's find out. It seems that I'm going just fine. I can move the other implementations for new releases here. Days rented. So I need to move this one here. Okay. And I'm going to move this one here. So the refactoring process is not important right now, but I'm just going to show you one very simple example. Obviously, you can use any techniques based on your needs and your requirements here. I'm just gonna finish this one here and this one here. So what I'm going to do is to remove this one, and I'm going to get the price code here, which is obviously a simple implementation based on the price code. So going to change this one. I think this one from here. So what I can do is to return different classes based on the type, and so Okay, what I need to do here is to ask my price code to calculate this one for me, and then I made a mistake here, and then obviously call this method to okay, let's see if I'm going fine right now. So it seems that everything is fine. My tests are passing. You can put a debugger here and check the values. There are lots that the frameworks will give you. You can obviously change the way the framework generates the values. You can write custom generators. There are lots of features to property-based testing, like shrinking, like many other features that will give that the frameworks will give you, and they're very powerful and useful features. So that's the whole idea. You can obviously continue this process to whenever you want. For example, moving this class or whatever you need to do with your code. So the basic idea, as you saw, is to write a property that asserts the value of the refactored code against our legacy code. So after that, you can obviously remove the movie rental class and get rid of that one, and for example, write some example based for that. I don't know, you can do whatever you want, but the process and mechanics are always the same. No matter if you use unit testing, if you use integration testing, if you use acceptance testing, and the frameworks will give you lots of features like stateful properties and that kind of stuff. Hope you enjoy that. Thank you for being in this session. I'm eager to hear your feedbacks. Thank you so much. Goodbye.
Hadi, that was great. Thank you very much.
Thank you so much.
And for those of you that don't know, if you go to the DDD Discord server, there are chat channels in there for each of the sessions, and I'm sure that Hadi will keep an eye on them if you've got questions and you want to carry on the conversation. With that, I'm going to end the broadcast. Hadi, thank you very, very much from myself and everybody at DDD, and thank you all for watching.
Thank you so much.